Most of us take it for granted that we know how the world works. We drop an apple and it falls. We look at the sky and see planets orbiting the sun. We assume gravity pulls things down, like an invisible hand. But what if we've been thinking about it all wrong? What if gravity isn't a force at all? What if the true nature of space and time is far stranger and more beautiful than anything we ever imagined? Today, we're going to explore a theory that reshaped our view of the universe forever. A theory born not from complex machines or massive teams of scientists, but from the mind of a man who simply refused to accept the obvious. This is the story of general relativity and how to truly understand it without needing to be a physicist. Let's begin. Imagine you lived in the 1600s. You look up. The moon is floating. The sun rises and sets. No one knows why. Then, a man named Isaac Newton proposes something radical. That all things, from apples to planets, are pulled by a force. This force, he says, is gravity. It acts instantly across space. It pulls objects toward each other, no matter how far apart. And for centuries, this explanation worked. We built telescopes, rockets, even landed on the moon, all using Newton's laws. But in the early 1900s, another man appeared, one who thought even deeper. He asked a dangerous question. What if gravity isn't a force at all? That man was Albert Einstein, and what he proposed would challenge everything. Einstein didn't just study numbers. He visualized the universe as if it were alive. He imagined space and time not as separate things, but as one combined entity, space-time. Now picture this. You lay out a giant rubber sheet. Place a bowling ball in the middle. The sheet dips, curves downward. That bowling ball, it's a planet. The curve, that's space-time bending. Now roll a marble across the sheet. It doesn't go straight. It curves inward, drawn toward the bowling ball. Not because it's pulled, but because it's following the curvature. Einstein said, mass bends space-time. Objects follow that bend. That's what gravity really is. Let that sink in. Gravity is not a pull. It's the path things follow when space itself is warped. In simple terms, it's a theory that describes how space and time bend in response to mass and energy, and how that bending affects everything from falling apples to the birth of galaxies. And it leads to one elegant truth. Mass tells space-time how to curve. Curved space-time tells mass how to move. Imagine space-time as a kind of invisible terrain. A flat landscape would mean no gravity, but introduce a mountain, a star, a planet, and suddenly the terrain slopes. Everything nearby rolls toward it, naturally. That's gravity, not a force, but the shape of the universe. Einstein didn't just say space can bend. He said time bends, too. That means time doesn't flow equally everywhere. The closer you are to a massive object, like Earth, the slower time passes for you. This isn't philosophy. It's science, proven by experiment after experiment. Real-world example. GPS global positioning. Satellites orbit the Earth thousands of miles above us. Because they're farther from Earth's gravity, time moves slightly faster for them. If we didn't correct for this, GPS systems would be off by 10 kilometers every single day. Einstein's insights are not just academic. They're inside your phone. Let's play with imagination for a moment. Two twins. One stays on Earth. The other gets in a spaceship traveling near the speed of light. When they reunite, the twin who traveled is younger. Why? Because moving fast slows down time. Not metaphorically, literally, biologically. Your heart would beat slower. Your cells would age more slowly. Your now would be stretched. That's the essence of relativity. Time and space are not fixed. They are dynamic, responsive to speed, gravity, and energy. What if a star collapses in on itself? What if it becomes so dense, so massive, that it bends space-time into a pit so deep? Not even light can escape. That's a black hole. And it's not fiction. It's a direct consequence of general relativity. At the center of every black hole is a singularity, a place where the fabric of reality folds in on itself. Einstein predicted them, reluctantly. Even he was afraid of what they implied. But in 2019, over a century later, we photographed one, a blurry ring of light surrounding a shadow. It was real. And Einstein, once again, had been right. A team of scientists detected gravitational waves, ripples in space-time caused by two black holes colliding. Think of it like this. Drop a pebble in a pond. Ripples move outward. Now imagine space-time as the pond, and colliding black holes as the pebble. The universe wobbled. That wobble traveled across billions of light years and nudged our instruments here on Earth. It was the first time we heard the universe speak. So let's step back. If time can slow, if space can curve, if gravity is just the shape of reality, then what else might we be missing? Einstein's theory doesn't just describe the cosmos. It changes how we see truth, experience, and even identity. Because the truth is, we are all traveling through a universe that is bending, stretching, shifting beneath us. And in that realization is something deeply humbling, and also something empowering. General relativity isn't just for scientists. It affects your GPS, your mobile network timing, satellite data, astronomy, every deep space mission ever launched. It's the reason we can see black holes, understand dark energy, and map the expanding edge of the universe. Einstein didn't just give us a theory, he gave us a language to read the cosmos. Einstein once said, "Imagination is more important than knowledge." And perhaps that's the greatest truth of all, because this entire theory, one that redefined reality, came not from machines, but from a man sitting in a chair, daring to think differently. So the next time you look up at the stars, or feel the weight of the earth beneath your feet, ask yourself, what if reality is more flexible than you think? What if time, space, and destiny are all just curves in a greater design? And what if your own imagination is the most powerful force of all? If this journey made you think, even for a moment, like, subscribe and share it with someone curious. And remember, the universe is not static, it's alive, and your understanding of it can evolve too.